Rebecca Corona.
I'm John Jefferson.
And my name is Erin Tangulonis, and today we'll be introducing our product and biotech company called Forti Potato. So to understand our product, let's first talk about the importance of calcium and vitamin D in the body. According to the National Osteoporosis Foundation, calcium is a mineral the body needs for bone health, blood clotting, and nerve impulses. Calcium must be obtained through the diet because it cannot be naturally produced in humans. However, in order for calcium to work properly and maintain all of these bodily functions, it has to be coupled with the hormone vitamin D. So, vitamin D, like I said, is a hormone, and calcium is important to our health. But unfortunately, calcium and vitamin D deficiencies are a global concern. According to the Centers for Disease Control, nearly 33% of the U.S. population is deficient in vitamin D, with females 4 and older and males 9 to 18 and 51 and older at the highest risk. So let's talk about some different sources where you can obtain vitamin D and calcium. There are several foods that are rich in calcium, such as almonds, broccoli, okra, and kale. And there are also foods high in vitamin D, such as cheese, yogurt, milk, and other dairy products. Additionally, being in sunlight can help your body synthesize vitamin D. Vitamin D foods, however, aren't necessarily naturally rich in vitamin D. Sometimes they are fortified, so you may have seen vitamin D milk advertised in grocery stores. That's typically an added vitamin D content to what is naturally there. However, calcium-rich foods and vitamin D-rich foods don't really overlap too much, so that's where the idea for Forti Potato came in. We decided to develop a nutrient-rich potato genetically modified to be insect-resistant. We chose to fortify potatoes because they're consumed worldwide. In fact, potatoes are considered a staple food, basically meaning they are widely consumed and they're able to be stored for long periods of time without decay. So, I mean, just if you think of the shelf life of a potato based on the shelf life of maybe a head of lettuce, you have to keep it refrigerated. It goes bad even in the refrigerator. A potato is usually stable just in the basement or at room temperature. And although potatoes are root vegetables, it doesn't mean that they are completely immune to insects. Soil insects such as wireworms, flea beetles, potato tuber worms, and grubs all feed on the potato root, which is basically the part that you eat. And therefore, to make our crop hardier and have better growth yields, we are going to add a component that protects against insects. So let's talk about specifically what we're going to do. We're fortifying potatoes with vitamin D and calcium to combat these global deficiencies that I talked about. Like I mentioned, 33% of the U.S. lacks appropriate vitamin D levels. Vitamin D can be synthesized in the body from sun exposure, so nations that don't get much sun or like Ohio, are likely to have such deficiencies. In countries that don't have adequate access to refrigeration may lack calcium, which is found in dairy products and those vegetables that I talked about, okra and kale. So like I said before, vitamin D and calcium work together, so getting one or the other isn't quite enough to maintain all of those bodily functions. So we aim to create a product where you can obtain both nutrients in sufficient levels at the same time. And additionally, we're going to add a gene that encodes for Bacillus thuringiensis protein for insect resistance. This protein penetrates and collapses insects' gut linings, which causes the insects to die. Okay, so we're going to talk about the process we will use to genetically modify our potato seeds. First, we're going to isolate vitamin D and calcium. Vitamin D is a hormone and it can be made synthetically, and calcium is a mineral, so it's also easily isolated. And then we will also have to isolate the Bt gene from the Bacillus thuringiensis bacteria. We will then insert the gene into a vector that has an antibiotic resistance gene, which will be important when we talk about the purification of our product. We insert the antibiotic resistance vector into bacteria, and then we will coat nanoparticles with gold or tungsten with the DNA vectors to prepare for insertion into the plant cells. We load the vector-coated particles onto a Teflon bullet, and we're able to load the bullet onto a gene gun. And when we shoot the gun, it will release the particles at an extremely high velocity into the potato cells, where it will incorporate into the plant genome. So once the Bacillus thuringiensis gene and the vitamin D and calcium are incorporated in the plant genome, the BT protein begins to be produced, and the cells are also expressing higher levels of calcium and vitamin D. So then we plate the cells onto selective antibiotic media to grow for a little bit until they get to a form where we can actually plant them in soil and get seedlings. This is where we sort of transfer our product process from the lab into maybe a greenhouse or a farm. And once we have the seedlings, we can develop them, obviously, into potatoes, which we will use as our product. So here's an overall flow chart of just what that process looks like. Like I mentioned, the greater portion of our process is going to happen in one of our laboratory settings. And then once we get here, we will need to couple with farmers to actually grow our plant. So we need to develop a strategy to characterize the potatoes to ensure they're actually expressing calcium and vitamin D and that BT protein. And we can do this using high-performance liquid chromatography. HPLC is a technique that is able to separate, identify, and quantify different components in a substance. It is using a liquid form, so we would actually have to develop a process to sort of liquefy our potatoes and not purify, but filter them so there aren't any large chunks. And then you have specific columns where your specific components, let's say vitamin D, would adhere to the column, and you run a certain solvent through it based on any type of structure from your compound, such as polarity, where it'll eventually flush out and you can identify and quantify your product. We also need to go through animal trials and human trials to ensure the safety and efficacy of our product. We will have the Food and Drug Administration approve it for human consumption. And then just a review, some of the main materials we need are DNA vectors, gold nanoparticles, and the gene gun. And then some of the smaller things that we need, but still very important to the process, are the potato seeds, the growth media, and the Bacillus thuringiensis bacterial colony. So that kind of wraps up the scientific portion of our product, and now I'm going to turn it over to John to explain the marketing aspect.
Well, to start off with, we will be located in Boise, Idaho, because when everyone thinks potatoes, you always think of Idaho. And we want to go global because there's a lot of nations around the world that are malnourished in calcium and vitamin D. We also we will be able to lower the rates of osteoporosis due to one of the main causes for osteoporosis is a deficiency in vitamin D. And osteoporosis, if you didn't know, is a disease that causes bones to lose their health and become brittle. And according to Insider Monkey, the 11 countries with the highest rate of osteoporosis are the United States, the United Kingdom, Sweden, Finland, China, Russia, Brazil, Australia, Canada, Germany, and France. And none of those nations, when you think of our third world or underprivileged nations, they're all world leaders or first world nations that are large parts of our economy and provide a lot for our the planet. And we are the first genetically modified potato on the market, and it's fortified with vitamin D and calcium. And world nations that have deficiencies are going to be our target, and many of them have use potatoes mainly in their diet. And also or something that can come from this too is potato is a large ingredient used in vodka, which would also then there'd be more vitamin D and calcium in vodka, which would also be an unintended cause from our product. And we want to try and give everyone access. We want to provide a product at a low cost that can benefit the people of our planet. And for our awareness of our product, we want to advertise as much as we can, but given that our product is not something that you're going to generally advertise to the public as much, we want to focus more on farming magazines and more on the internet, given that we want to target the farmers who are going to be purchasing our seed to plant it, not go after the general public who really is not going to be a large market for us considering we're selling the seed. And we just want to keep the price low, given we are the only we don't want to just become a monopoly and overprice our seeds and price us out of the market. And we want to keep it low until the effects of our product are shown, and it's shown that there is vitamin D and calcium in our product, not just we're some regular potato seed trying to sell it and there is no benefit to our seed, but we want to show that before we raise our prices. And delivering, we want to try and deliver the most value for the lowest amount of money we possibly can and keep it as cheap as possible while still making a profit. And given that we are selling a seed, we don't really have any after sales, or we don't really need much customer service afterwards, because after you buy the seed, you're on your own for growing the seed. There's not much we can do in terms of you growing the seed. Our key partners are going to be with hardware stores and then internet distributors. We're also going to try and work with governments in third world and developing nations to sell our seeds to them, to grow them. And then shipping companies and wholesale retailers. For our cost structure, we will be roughly around it'll cost us $150,000 to start up. And our lab space, it could be anywhere, depending on how big of a lab we want to start with in Boise, it could be anywhere from 11 to 1325 a square foot per year. And there's space for 1,600 square foot all the way up to 12,000 square foot, depending on how big of a lab we choose to build. And the gene gun will be roughly around $20,000 budget. And for lab equipment and material costs, $100,000. And we would like to set aside some money and put it in the budget in case we run into any legal issues, so we have money for if we have to go to court to hire lawyers. And we plan to go public to start. And now I'm going to hand it over to Rebecca for the legal and ethical.
Okay, so I'm Rebecca Parada. I'm the legal and ethical consultant for our company. So today I'm going to be discussing the three major legal and ethical uncertainties that the public typically have with genetically modified foods. And I'm going to discuss how our company effectively assesses these concerns. So the first big concern is whether or not a product is properly labeled, stating whether it is or isn't genetically modified. The second is potential environmental effects that genetically modified foods or genetically modified crops may have on the environment. And the third is potential health effects that genetically modified foods may have on humans. And I'm also going to be discussing a company that has recently gone through a lawsuit for falsely labeling their product. Okay. So a poll done by the Center for Food Safety in 2016 states that 89% of voters say that they favor mandatory labels on foods which have been genetically modified or contain genetically modified ingredients. According to the FDA, in the United States, foods that are considered genetically modified are required to disclose it on the food label in one of the following ways. It can be just plain text on the label stating that it's genetically modified. It could be a symbol, a picture. There can be a phone number that customers can call to receive GMO information, or it can be a barcode that links to a website displaying GMO information for the product. Because there's such controversy and skepticism today on whether or not genetically modified foods should be labeled, many countries have different laws regarding the labeling of these genetically modified foods. Because we plan to sell our fortified potatoes globally, we will be labeling our product to state that it's genetically modified in order to stray away from any legal issues. Also, because our focus is on malnourished countries, we believe that the demand for food and nutrients will outweigh the potential concerns for genetic modifications. Therefore, we don't believe a label stating that our product is genetically modified will affect our sales. According to the EPA, the Environmental Protection Agency, they regulate biopesticides such as the Bt toxin, otherwise known as Bacillus thuringiensis, which, as we previously discussed, is the protein we incorporate in our potatoes for insect resistance. Under the Federal Insecticide, Fungicide, and Rodenticide Act, or the FIFRA, if a crop is genetically engineered to carry a gene for the Bt toxin, the EPA requires that the company verifies that the toxin is safe for the environment and conducts a food safety analysis to ensure that the foreign protein is not allergenic. Therefore, we will demonstrate to the EPA that although we incorporated the Bt toxin into our fortified potatoes, they are still environmentally safe and able to pass a food safety analysis. Along with controlling labeling requirements for genetically modified foods, the FDA also regulates the genetically modified crops themselves. They decide whether or not a product is recognized as safe to consume, and if they decide that it's safe to consume, then they don't require that the product is pre-market approved. However, if the insertion of the gene into the food crop results in expression of a foreign protein significantly different in structure or function from the natural plant's proteins, then pre-market approval is mandatory. Therefore, we will prove to the FDA that our product does not express foreign protein significantly different from a natural potato's proteins, and we will not have to go through pre-market approval, and we will therefore be approved by the FDA. So, as we previously stated, our company is going to label our product as genetically modified for multiple reasons, and I just want to give an example of what can go wrong if you mislabel your product. So, most of you probably know the company, or the healthy cereal brand Kashi. Well, they're owned by Kellogg's, and according to CBS News, in 2014, Kellogg's had to pay $5 million to settle a lawsuit for mislabeling their product as non-GMO. A consumer lab test was done and showed that almost 100% of both their soy and corn used in their products are genetically modified. Kellogg's also paid $1.6 million to defeat GMO labeling initiatives. So these are the type of lawsuits and problems we're avoiding by properly labeling our product as genetically modified. So our inspiration for this project was to address a worldwide deficiency with a universally consumed food item. We used genetic modification to fortify potatoes with vitamin D and calcium, as well as an insect-resistant component. We plan to sell these potatoes to malnourished countries all over the world to attempt to put an end to this global health issue. We open the floor for any questions.